Good morning, everyone. I am delighted to welcome you all today. Thank you for joining this session. Today, we will be discussing a very important topic, the procedure for qualification of Excel sheets used in QC lab calculations. This presentation will walk you through the necessary steps to ensure these sheets are reliable and compliant. We'll cover the key aspects of validation, documentation, and best practices to make your QC processes robust. Let's get started and make this session informative and engaging. Today, I want to talk about the qualification of Excel sheets in our QC laboratory calculations. First, let's look at the scope. This procedure covers all Excel spreadsheets that we use for key QC calculations. That includes assays, content uniformity, dissolution testing, impurities, and other related processes. It's important because these spreadsheets are integral to our data analysis and decision-making. Next, the purpose of this qualification process is to establish a regulated, risk-based approach. What does that mean? It means we evaluate and qualify Excel files in a way that prioritizes the most critical data and processes. Our goal is to ensure data integrity, meaning the data is accurate and reliable. We also want to maintain traceability, so we can track all changes and ensure compliance with applicable electronic record regulations. By implementing this approach, we help safeguard the quality and compliance of our laboratory data. It's about making sure our Excel tools are fit for purpose and meet regulatory standards, ultimately supporting our overall quality assurance objectives. Let's take a closer look at the qualification of Excel sheets in the QC laboratory calculations. First, the key term here is qualification. This refers to documented evidence that an Excel sheet not only works as intended, but does so reliably within a controlled environment. It's about ensuring that the calculations we rely on are accurate and consistent. Now, when we talk about validation versus qualification, it's important to understand that in this context, qualification specifically means testing the Excel sheet for its intended use. It's a more focused process, making sure that the spreadsheet performs correctly for the specific calculations we need. Another critical point is the calculation ID. Think of this as a unique identifier assigned to each spreadsheet calculation, like CALC Assay 001. This helps us keep track of each calculation, ensuring traceability and accountability in our data management. Overall, these concepts, qualification, validation, and calculation ID, are fundamental for maintaining the integrity and reliability of our laboratory calculations. They help us uphold quality standards and ensure that our data is trustworthy. When it comes to regulatory requirements, there are several key standards we need to keep in mind. First, there's FDA 21 CFR Part 11, which focuses on electronic records and signatures, as well as the validation of electronic systems. This ensures that electronic data is trustworthy, reliable, and equivalent to paper records. Then, we have EMA Annex 11, which emphasizes the control and validation of computerized systems used in pharmaceutical manufacturing. It's about maintaining strict oversight and ensuring systems are validated appropriately. Next, PICS good practices highlight the importance of a risk-based validation approach for software used in GMP environments. This means we assess and mitigate risks to ensure system integrity and compliance. And finally, ICH Q9 introduces a risk management approach, guiding us to systematically identify, evaluate, and control risks associated with our processes and tools. Specifically for our context, Excel must also be validated or qualified as a controlled calculation tool. This is crucial because it's often used for critical calculations, and we need to ensure its outputs are accurate and compliant with these regulations. Overall, these standards and practices are about ensuring our electronic systems and tools are reliable, validated, and compliant, supporting quality and integrity across our operations. Let's take a closer look at roles and responsibilities. In any project, clearly defining who does what is absolutely essential for success. This slide highlights the importance of understanding each team member's key responsibilities to ensure smooth collaboration. When roles are well defined, it helps prevent confusion and overlaps, making sure everyone knows their specific tasks. It also promotes accountability, so each person understands their contribution to the overall goal. As we connect this to our broader theme of effective teamwork, remember, clarity in roles not only streamlines processes, but also boosts morale, since everyone knows they have a vital part to play. So, establishing clear responsibilities is a fundamental step toward achieving our project objectives efficiently and effectively. Let's take a closer look at the qualification lifecycle overview. First, we start with risk assessment, which is all about identifying potential risks early on to ensure we focus our efforts on what's most critical. Next comes specification and design, where we define the requirements and create detailed plans to meet those needs. Then, we move into test script preparation, developing the specific tests that will verify our design against the specifications. After that, we execute the tests, carefully carrying out each step to gather accurate data. Once testing is complete, we evaluate the results to see if the system performs as expected and identify any issues. Documentation and approval follow, ensuring all findings are recorded and formally approved before moving forward. Finally, we have change control and requalification, which involves managing any necessary adjustments and revalidating the system to maintain compliance. This entire life cycle is essential for ensuring quality and reliability throughout the product's life. Let's take a closer look at the risk matrix and how it's used to determine which tests are necessary. Essentially, this tool helps us evaluate different risks by considering both the likelihood of an event occurring and the potential impact it could have. By mapping these factors, we can prioritize testing efforts more effectively. The goal here is to identify the areas that pose the highest risk so we can focus our resources where they matter most. This is a key part of risk assessment, which underpins the entire testing process. Using a risk matrix ensures that we don't waste time on low-risk issues, and instead, concentrate on testing scenarios that could cause the most significant problems if overlooked. It's a strategic approach that keeps our testing aligned with overall project safety and quality goals. So, in summary, the risk matrix is a practical, visual tool that guides us in making informed decisions about testing priorities based on risk levels. This helps us manage risks proactively and ensures we're covering the most critical areas thoroughly. Let's walk through the key specification elements that are crucial for this sheet. First, we need to clarify the purpose and scope of the sheet itself. This helps everyone understand what the sheet is designed to do and the boundaries of its application. Next, input parameters are essential. We specify what inputs are needed, along with their units and acceptable ranges. This ensures data consistency and accuracy in calculations. Then, we move on to output definitions. Clearly defining what outputs the sheet produces helps users interpret the results correctly and use them effectively. Following that, understanding the calculation logic is vital. We reference formulas used, so users know how the outputs are derived from the inputs. This transparency supports validation and troubleshooting. Lastly, error handling and protection levels are important. We need to specify how errors are managed and what protections are in place to prevent incorrect data or calculations from affecting results. For example, consider a calculation ID like CALC assay 001, which uses a formula based on USP methods for percent assay. This snippet illustrates how specifications are documented and integrated into the overall design. By covering these elements thoroughly, we ensure the sheet is reliable, transparent, and aligned with quality standards. This also ties into the broader theme of building robust and compliant data management systems. Now, let's take a closer look at the development of a comprehensive test plan. First, it's important to understand that the test plan includes several key components. One of these is test scripts that are directly mapped to specific requirements, ensuring that each requirement has a corresponding test. Next, we define the expected results for each test, so we know what success looks like. We also establish clear pass or fail criteria, which helps us objectively determine whether a test has succeeded or not. The traceability matrix is another crucial element. It provides a clear link between requirements and tests, making it easier to track coverage and identify any gaps. To give you a practical sense, some example tests might include an input validation test, which checks whether the system correctly handles various input scenarios. Then there's the formula accuracy test, ensuring calculations are precise. Boundary condition tests verify the system's behavior at the edges of acceptable input ranges, and protection or control tests confirm that safety features are functioning properly. Overall, developing a solid test plan is essential because it guides our testing efforts systematically and ensures we thoroughly validate the system against all requirements. This structured approach ultimately helps us deliver a reliable and quality product. Now let's look at the test outcome, which involves comparing the Excel output to the expected results. This step is crucial to ensure our calculations are accurate and reliable. The example we're using is a calculation identified as CALC assay 001, and its purpose is to determine the percentage of assay for the API, or active pharmaceutical ingredient. The core formula we're applying is percent assay equals the sample area divided by the standard area, multiplied by the standard purity divided by the sample weight, and then all that multiplied by 100 to get a percentage. In Excel, we replicate this calculation with the formula equals B3/C3 asterisk D3/E3 asterisk 100. It's important to understand the logic behind this formula. The cell references B3, C3, D3, and E3 correspond to the sample area, standard purity, and sample weight, respectively. Using this approach, we can verify that our Excel calculations match the expected theoretical values, ensuring our assay results are both accurate and consistent. This comparison helps us catch any discrepancies early, maintaining the integrity of our data and supporting reliable quality assessments. Now let's look at some sample data for individual content values, which are measured in milligrams. For example, we have values like 98.5, 101, and 99.8 milligrams. The goal here is to analyze this data to understand its distribution and variability. First, we'll compute the average, or mean, of these values. This gives us a central point that represents the typical content in our samples. Next, we'll calculate the standard deviation, specifically the population standard deviation, which tells us how much the individual values vary around that average. Additionally, we'll determine the percentage content for each sample relative to the label claim. For example, if the label claim is 100 milligrams, we want to see what percentage each individual value represents. To do this, we use the formula. Percent content equals the individual content divided by the label claim, times 100. In Excel, this is implemented with a simple formula, equals F2/100, 100, assuming F2 contains our individual content value. By performing these calculations, we ensure content uniformity across our samples, which is critical for quality control. These steps help us verify that each product contains the right amount of active ingredient, maintaining consistency and meeting regulatory standards. Let's talk about documentation first. It's essential to keep a clear record of our test scripts, so we know exactly what was tested and how. We also need to document the actual results versus what we expected to happen, which helps us identify any discrepancies. If a test fails, we should thoroughly investigate the deviation to understand the root cause and address it properly. Now, moving on to the execution of tests. The process starts with preparing our test data, which should include normal, boundary, and erroneous cases. This ensures we cover all possible scenarios. Once the data is ready, we lock the calculation cells to prevent any accidental changes during testing. Then, we enter our test data into the system. After entering the data, we validate the results by comparing them against manual calculations or an independent reference. This step is crucial to verify accuracy. Finally, we record whether the test passes or fails based on this comparison. Keeping these steps organized and thorough helps us maintain the integrity and reliability of our testing process, which is vital for the overall success of our project. Let's talk about version control now. Every time we make a change, a new version is created, which helps us keep track of our progress. Maintaining a version history is essential because it allows us to see what changes were made over time. And having a change log with justification means we can document why each change was necessary, making collaboration much smoother. Now, moving on to protection, version control, and security. These are critical to safeguarding our work. We can protect entire sheets or workbooks to prevent accidental edits. Locking specific calculation cells ensures that key formulas aren't unintentionally altered. Restricting editing rights helps us control who can make changes, and password protection adds an extra layer of security, making sure only authorized users can access sensitive information. All these measures work together to keep our data safe, accurate, and reliable, which ties back to our overall goal of maintaining integrity and security in our work. Now, let's talk about the documentation and approval process. This is a crucial step to ensure everything is properly validated and meets our quality standards. First, we need the required documents, starting with the qualification protocol. This includes the risk assessment, specifications, and test plan, basically the blueprint for how we'll verify the product's performance and safety. Next, we have the test script and results, which detail the specific tests conducted and their outcomes. These provide a clear record of how the product was evaluated. The traceability matrix is also key. It links all the requirements to their corresponding test cases, ensuring nothing is overlooked. Then there's the summary report, which consolidates all findings into a comprehensive overview. And finally, the ultimate approval comes from the QA team, who reviews all these documents to certify that everything meets the necessary standards. This process is all about thoroughness and accountability, making sure we deliver a reliable, compliant product that aligns with our overall quality goals. So, to wrap things up, let's talk about the key takeaways from our presentation. First, having an Excel qualification is crucial because it ensures the data we work with is accurate and maintains its integrity throughout the process. This is fundamental in making reliable decisions and maintaining trust in our results. Next, it's important to highlight that our approach fully aligns with regulatory expectations. This means we're not just doing things correctly, but also in a way that meets industry standards and compliance requirements. Additionally, our process requires structured testing, thorough documentation, and strict control measures. These steps help us catch errors early and keep everything transparent and reproducible. And to make sure every calculation can be traced back easily, each one is assigned a unique calculation ID. For example, you might see IDs like CALC Assay 001 or Calc CU 002. These IDs are essential for traceability, especially when audits or reviews happen. Overall, these elements, qualification, compliance, documentation, and traceability, are the backbone of a robust and reliable data management process, and they tie directly into our overall goal of ensuring data quality and regulatory readiness. For further support, please don't hesitate to reach out. We're here to help you with any questions or additional information you might need. Thank you so much for your time and attention today. I truly appreciate your interest and engagement. If there's anything more you'd like to discuss or clarify, please contact us through the provided channels. Remember, we're committed to supporting your success beyond this presentation. Once again, thank you, and I look forward to connecting with you soon.